A very good morning to you guys. Today we need to look at standard algorithms. Standard algorithms. Okay. Now, standard algorithms came as a result of something. Okay. So we are saying since computers were created, users have devised programs, many of which needed to do the same thing. All right? So as a result, standard algorithms have evolved and been adopted in many programs. Now, we have two types of algorithms that are often used to include. We have two types of algorithms that are often used. Okay? The first one is we have searches. And the second, we have sorts. Okay? So these are two types of standard algorithms that are used. So someone may ask, say, what is a search and what is a sort? Okay? Now, search enable a data set to be examined. A search enable a data set to be examined and a specific item to be found, and a specific item to be found. All right. On the other end, we have sorts. What do these sorts do? These ones, they enable data sets to be sorted into order. Enable data set to be sorted into order. Okay? That is sort. Now, with standard searching algorithms that I want to discuss with you, with standard searching algorithms. Okay, but before we look at standard searching algorithms, we're talking about a sort. So we are saying a sort enable a data set to be sorted into order. At times you might be given a data set which is in an orderly manner, right? Maybe it's writing 3, 5, 7, 9. maybe you are to actually sort into from the smallest number to the largest, or from the largest to the smallest. Okay, so this is when we use sorting algorithms. Now let's now go on to standard searching algorithm. The first standard searching algorithm that we have is called the linear search. So number one, we have the linear search. Number two, we have what is known as the binary search. Okay. Then we also need to look at standard sorting algorithms. Standard sorting algorithms. Okay, number one, for the standard sorting algorithm, we have the quick sort. Number two, we have the bubble sort. Okay, but in this particular lecture, we are only going to look at the linear search for the sake of our time. Okay, so in this particular lecture, we need to look at the linear search. Okay, now what is a linear search? I think that's the first question we should ask ourselves. Now, a linear search is the simplest method of searching a data set. A linear search is the simplest method of searching a data set. Okay, that is a linear search. So starting at the beginning of the data set, each item of the data set is examined until a match is made. All right, so this is how it works. We start at the beginning, searching element by element until we find our match. So once the item is found, the search will end. At times, you might realize that the search will even end at the beginning, because maybe the element we are looking for might be found at the beginning of the search. So if there is no match, the algorithm must deal with this as well. So right now, I want to write a written description algorithm for linear search. An algorithm for linear search. Okay, all right, we start with number one. The first thing we need to do when performing linear search is to find out the length of the data set. Find out the length of the data set. Okay, that's the first thing. Number two, we need to set counter to 0. We need to set counter to 0. Okay, so by finding out the length of the data set, we need to know kuti counter yedu inofana kuperera papi. If the data set has got 6 elements, it has to be defined at the start that our data set its length is 6. All right, so that the counter inozape kugumira kuti ndikubva pa 0 kusvika pa 6. Okay, then by setting the counter to 0, we are ensuring that the search starts at the beginning of the data set. All right. Number 3, we examine value held in the list at counter examine value held in the list at the counter position. At the counter position. Okay, so here we are saying we need to examine the value held in the list at the counter position. So if the counter is set to 0, it means we are looking at the first element. So if the first element matches what we are looking for, then the search will end there and there. Okay, now move to number 4. We check to see if the value at counter position matches. Check to see if the value at counter position matches. Okay, matches the value searched for. Matches the value searched for. So we need to check the value at the counter position to see if it matches the value that we're looking for at step number 4. Then we move to step number 5. Now at step number 5, if it matches, the value is found. If it matches, comma, the value is found. Okay, if the value is found, send a message and end the search. Send a message and end the search. Okay, that's step number 5. We now move on to step number 6 of our algorithm. If not, okay, so on step number 5 we're saying tikawana value ya trukuda the session of the end, then you send a message kuti the match is found. All right, but if not, we increment the counter by 1. If not, increment the counter by 1 and go back to step 3 and go back to step 3 until there are no more items. Until the hello? Then? Hello? All right, until there are no more items to search for. Until there are no more items to search for. Okay? So this is what will happen at step 6. So we move to the last step, which is step 7. If all items have been checked, if all items have been checked and no match is found, and no match is found, send a message notification. Send a message notification. Okay. Now, I would like you to consider the list of unordered numbers. Consider the list. Okay. I want you to consider this list. It is position, in data set, then data value. Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7. Okay, then the data values are with 3 here, we have 5 here, we have 2 here, we have 9 here, we have 6 here, we have 1 here, we have 8 here, we have 7 here. Okay? Now, suppose we have to search for value 2 in this list. Okay? So here you'd realize that the search would start at position 0 and check the value held there. As you can see, at position 0 we have 3. Okay? 3 does not match 2. In this case, we are looking for 2. So 3, which is at position 0, is not what we are looking for. So we move to the next position. The next position, which is 1, has got 5 as the data value. We are not looking for 5. We are looking for 2. So we also move to the next position. So at position 2, there is 2. This is where our match is. Remember, we are looking for 2. So in such a case, the search will end at position 2. All right? Now, let us look at a pseudocode. For linear search. Now, what does the pseudocode for linear search say? So if you're following whatever I was saying at the beginning, I'm sure you understand this. So we set find to 2. Okay? Because the element we are looking for is 2. All right? Then we set found to false. Why are we setting found to false? Because pese patenge tisina kuwana what we are looking for, it means we have found a false value. That's why we are setting found to false. Then we also set length to length list. Okay? By setting length to length list, we want to ensure kuti counter ichapera pati. Okay? Then we also set our counter to 0. By setting our counter to 0, we want kuti itangire pane the first element ichita move with the list. All right? So now we say while found equals to false, while found equals to false and counter is less than length, and counter is less than, and our counter is less than length, do if So we are saying if our counter is less than length, it means counter is supposed to exceed the length that we are given. Okay? So do if list counter is equal to find. So tukuti the counter each per statement list square brackets counter equals to find. We are saying icharamba ichienda ichitsvaga counter ichienda pa next kusvikira counter equals to find. Find, remember, that's 2. Patachiti set find equals to 2. So finder is equal to 2. Okay? So we do if list counter equals to find. Then set found to true. Then set found to true. So kanataona 2, we now set found to true. Found was once set to false. So kanataona the value yedu mu list yedu, we now set found to true, I mean. Okay? And then we send a notification. So we send found at position, found at position, we put our bracket, and counter. Okay, so this is how you write your pseudocode. Then to display else counter, else set counter to counter plus 1, else set counter to counter plus 1, or else you need to set counter to counter plus 1 because the match inogona kusawanikwa pa true kuda isusu. Okay, then end if, and we end the while. Always remember to do this. You end the if and you end the while. Now if found equals to false, there are some cases which after counter iterator list race rinogona kushaya value yatrikuita look for. That's why we are saying if found equals to false, then so kana found equal to false, like pasina value yatambowana find by ita true, then it has to send a notification. So it's then send item not found, item not found. Okay, to display. We send this notification to our display. Then we end if. So this is how we write the pseudocode. Alright. Now as you can see, linear search is simple, but it is inefficient. How is it inefficient? Suppose the dataset contained 100 items of data, and the item searched before happens to be the last item in that set. Okay? We are given 100 elements. But for 100 elements, whatever we are looking for is at the last position, or the 100th element is the one that we are looking for. So it's inefficient in the sense that all the 99 items would have to be searched through first. Imagine. So it becomes slow, because for it to actually retain the value that you're looking for, it has to search through 99 times before it actually gives you the result. So that's why we say it is inefficient. It is efficient for very small data set, but if the data set has got more than got more numbers, it is a bit inefficient. But however, the linear search has the advantage that they work on any data set, whether it is ordered or unordered. They have to be in an orderly manner. Okay, they can be arranged haphazardly, but it can still search. Thank you very much for watching. I hope you have enjoyed this tutorial. If you have any questions, please let me know at 0784 002 002. Okay? And also don't forget to subscribe and like on my YouTube channel. Goodbye.